Thank you. Yeah. I think all of us want to talk and understand the hidden costs of cloud and and where are we bleeding money, right? So I've got this expert panel in front of me. We were just having this very engaging conversation upstairs, right? Where we were talking about, hey, is it all reality or it's all myth kind of thing, right? So let's debunk all the myths. We'll keep it very light, we'll keep it very fun for you, and I will ask them tough questions so that you can hear all of those answers, right? So my very first question, right, I want to address the elephant in the room. What's the most shocking cloud bill surprise you have encountered? And who was the culprit of it? You don't have to name people, right? You can skip naming people, but what was the culprit and who was the culprit behind it? Would you like to start, Swadhin?
Hello everyone, good morning. Thanks for coming on Friday, and thanks Quanting India for inviting us. First of all, I'll start with who was the culprit. I was the culprit. So yeah, I remember 8 years back when I started my company, we were on AWS. We done amazing good on compute and storage, and we wanted to move to GCP. And we were not aware of egress cost, and that was a hidden cost which we got to know after the migration. And we saw 4x crazy sort of spike in the bill, and that was crazy for me because as a founder, it was not funded yet that time. So yeah, that was my experience like 8 years back as a founder of company, and I was the culprit for it.
That's great. Yeah. What do you think?
Awesome. Good morning, everyone. So this was a couple of years ago. So natively we are hosted Freshworks. Basically, I represent Freshworks. I head all of their cloud and responsible AI. And we are doing a POC on GCP, and this is for analytics product. And so the product is BQ, the BigQuery. And so always remember, any instrument that makes spending easier is where you should be very careful. It's like credit cards, right? So it's very easy, like you'll actually be able to spend money that you don't really have, and that's where the problem starts. So BQ, we started a POC, and the overall cost was supposed to be about $5,000 for a month or two. But then we set alerts on it, and then the next day I wake up, I get a bill alert for $60,000. Okay, this is just a night, like we went to the bed and came back and then $60,000. So one of the scripts, I think the entire data got loaded and it started running. And so that is the beauty with the serverless and the subscription cost kind of scenario. So the best part is we didn't wait for a couple more days for it to go to a couple of $100,000. So I realized it, we stopped it, and luckily I was able to get the whole refund back from the GCP, but that was a good experience.
Good morning, folks. There is a concept called sunk cost bias and opportunity cost, okay, in psychology. And usually there is always a tug of war between those two. So not my experience, but what I've observed over my journey in the last 18, 19 years is we always look at what is the next one which is going to give me a very good cost for the next year. We don't look at what does it take for me to go there. That is never taken care. So we always look at the opportunity cost as compared to the sunk cost, and then we lose out on it, right? That is one. And second, businesses, I think it's all about top down, right? If my strategy is growth, do whatever it takes, and then you just do it. But the moment you hit that threshold, you realize, now look at making yourself profitable. It's never this or that. It should be a balance. That is where we usually lose. It's all about the decisions at that point of time which creates the problem. Yeah.
Well said on that one, right? It's like sunk cost versus what's actually expense. Yeah, great. Please go ahead.
Yeah. Good morning, everyone. Good to see a lot of folks on the Friday morning, and thanks to Quantic India for arranging this event. So I tell my experience in terms of this. Last year, November, we were very deep into our MySQL 8 migration. We have set up a equivalent of a production cluster of our payments database to do this load testing. Then during the time of load testing, we have identified critical bug basically, where our change data capture is generating events which were not correct, because of which downstream systems were not able to consume. So we were working on debugging it, but the engineer who is working on it has to go on suddenly. He's a senior engineer who was working on it. Then some festive holidays were also there. During all this entire period, what happened is this infra was idle and then it was continuously running and it is accumulating costs for us. At the end of the month when we have seen, it is almost like $28,000 of additional bill has come to us. When we look into it, debugged further, we realized that this is the culprit, right? So what we have learned is, yes, cloud costs, idle resources are like killers. We have to be very careful, especially in terms of monitoring, tracking, doing anomaly detection, not just in the production environment, but also in the lower environments, we have to be very careful. Yeah, thanks.
Good morning, everyone, and thanks for having me here today. Very, very delighted to be part of this session. One interesting thing that I wanted to put forward, where I was shocked with the cloud bill was obviously there was a small use case where we had to get some, events, SQS events, and then we launched an SQS queue, and we kept it running. Obviously, one of the things that you want to do is to look at it day on day, but obviously people miss it, and then I am to blame for that. At the end of the month, we saw a huge bill coming out of just. I said, okay, what? There are about 5,000 events per day in SQS, and then why is it costing so much? And then it turns out to be that there was this consumer which was always doing the poll. And then it was polling, every poll you are charged, right? And then obviously we learned that, okay, you can do long polling, you can do batch polling, and then all sorts of stuff, especially for the use cases where the consumer doesn't need to be as active to be able to get lots of messages and serve in real time. When we learned that we could actually use something like a long polling and then batch polling, and then you could even have some bytes, let's say some few MBs, after which you can wait up to an MB or so. So we can do lots of stuff on that. I think that's where we significantly saved our SQS cost by about 70%. 70% of the total SQS cost was all just because of bad polling.
Wow, that's really amazing.
Yeah.
Hey, good morning, everyone. Thanks for having me here. So I will share a story. Okay, I mean, I think most of you guys would have multiple stories. I also have multiple stories. I picked one story because the story is very funny. It all started to be an optimization, right? We were using Elasticsearch. Even now we are using Elasticsearch. And if you guys know about Elasticsearch, it have a beautiful architecture of cold, hot, warm, cold. And you can have SSDs of multiple tiers to keep your cost on a lower side. So we have the same, and our cold node is in HDD, right? Because it's least accessed and other things. So Elasticsearch introduced for a support of blob storage type, right? Which will further reduce the cost. So we all got so excited, we jumped on and we start implementing it immediately in production after non-prod and other things. Then we realized people were still using graphs which was querying those cold storage, and also Elasticsearch by default try to distribute the load between multiple nodes to keep it in a consistent state, right? So it means a lot of reads as well as a lot of writes to keep the distribution on. Within a day we realized, because we had strong alerting mechanism in place, the cost increased by 25%. Luckily, we had the monitoring in place, so we caught it. I just wanted to share it because this is really funny. As I mentioned, it was an optimization went in a different direction.
It does happen. It does happen a lot of time. I talk to a lot of companies where optimization just went the other way if you are not careful about it.
Hey, good morning, everyone. So what I have seen in my experience that there are certain parts of our infrastructure where we have good observability, good monitoring, but then there are certain areas where we don't have that detailed observability. So one of that is your data analytics, data science, those kind of workloads. So we had one incident, then we saw our S3 API cost skyrocketing, like day by day, hour by hour, it's increasing. So we had our observability where we could see the cost increasing, but why the cost is increasing, right? When you have hundreds of buckets, thousands of objects with a lot of partitions, how do you nail down to that? So what happened was that we had a product launch. We wanted to, there's a campaign launch. So somebody in analytics, they created some tables, some files to do some analysis. And they did it in not an optimal way. So it ended up creating hundreds and thousands of files. And then they were like refreshing these data sets, these reports, dashboards, like every minute, every hour, every 30 minutes. So that skyrocketed the S3 API cost. So why it is hard to detect these kind of issues? Because building observability on top of S3 cost itself is costly, right? So it's not that costly that observability comes out of the box. For our, say, backend services, there is a good observability in terms of our auto-scaling rules. We know minimum pods, maximum pods. But then there are a lot of gray areas in terms of networking, in terms of storage, which are not, typically, which are not very, very closely monitored. So I think that's where we, in my experience, I have seen a lot of surprises coming from those areas.
That was really insightful, Vishal. Yeah.
Hi, thanks everyone. So for me, I'll give probably a couple of examples. One, when we actually tried to move our code base from non-prod to prod. With the scaling expectations, we increased the number of pods. We realized that that much of load is not required, but then there was a manual error. We could not bring them back, and that caused a big, massive bill. So I would say lack of real-time visibility was one of the main challenges that we had at the time. The other incident where there was a bigger bill was when we were doing our image processing. So at bigbasket, as you can imagine, the number of images that you would browse through when you are searching for something or when you are viewing the product details, we will be processing many images. So during the image processing, one of the challenges was that our caching was not proper. Basically, the images were not cached properly, and hence every time we had to process the images, and those number of API calls to the vendors and to the S3, and those things actually caused a bigger bill. So we learned it hard, but then it's also about where do you have to do the caching well, and where do you have to make sure that you, scale down when required. So these are the learnings that we had.
That's a great learning. And talking of budget, right, I have this question to Siva and Manoj, right? Why do cloud cost overrun happens even when we have budget control in place, right? Every year we do this meticulously planning that, okay, we'll spend these many $1 million in cloud, and we have done these all mathematics sitting for 2-3 hours, and still we overrun every year, right? And I'm pretty sure it is true for all of us, right? So why do cloud cost overrun happen even with budget controls? You can go ahead, Siva.
So as I just mentioned, visibility is one of the main challenges. So people would want to know in advance what is going on with respect to our cloud usage. Then only we can put some checks and balances in there. And also, it's also about accountability. So let's say you are you're an organization with, let's say, 10 different teams, and each team, if you are looking at your costs, then, for example, let's say, as I took the example of image processing, whose problem is that? Where is the accountability of not being able to cache them well? You cannot put it onto, one team. You cannot put it onto your own DevOps team. But then organization have to bear those, right? So how do you put that accountability? So I would say the so-called FinOps model, where you are actually bringing these people together, the development teams, product teams, finance teams, as well as your business teams together to make this happen, is something I would say should help us. But in spite of these things, the cloud bills continue to rise. Probably one of the other things that I can talk about is the unknowns. So there are a lot of ways that you can be billed, and if you are not aware or if there are hidden costs, let's say you have your APIs, there are certain services that you will be billed per API call. There are some services that you get billed based on number of calls that you make, number of customers that are accessing. So you should be knowing where you are actually calling what service and what is the model of that, and that's how you will be able to sort out.
Got it. So what I'm hearing from you is visibility, accountability, and understanding the unknown cost. And we can be there somewhere, right, to solve the problem.
Absolutely, yeah.
Great. Manoj, please.
Yes, adding to what Shiva has mentioned, right? I think many of you guys have mentioned this point time and time again, which is the egress cost or networking cost, which is a killer. I mean, like, I would request each one of you guys, go and see your networking cost. You will be surprised by seeing where and all your money is going, right? And as Shiva mentioned, I will reiterate on that point. Make sure all your static assets are cached well. If at the local device level or using a CDN or something, it helps you a lot. But yeah, to answer the question, where we will kind of overburn is lack of having granular monitoring. I will like to add that point. What I meant by that is, don't just monitor at the top level or at the environment or subscription level. Have it at the resource type level. That will give you a lot of insights. So having those monitoring in place with a buffer, like I cannot go more than 5% or 10% based on your cloud spend. So this is one primary reason we sometimes overburn, and a lot of learning will come. You can optimize it. And once you learned it, don't just keep it with the DevOps team. One thing I would encourage all of you guys, I won't call it as an accountability. It's our responsibility to educate our development team about these things so that we can avoid it from happening in the first place itself. Because those learning and sharing those learnings with everyone in the organization help you to keep it keep your cloud cost in control.
So what I just heard is knowledge is important and keeping a regular checks, right? On topic of keeping a regular checks, I have this question for you, Kausal and Ranjitha, right? What are the most overlooked sources in cloud waste, especially in multi-cloud or single cloud environment? What are the most common sources that we overlook, right? Manoj was just telling data transfer cost. What was for you? Yeah.
That's spot on, right? One of the most highest burns that you ever see is there. And then it's just not about caching or anything that will solve some of the static assets can easily be cached, and then you will be able to save a lot of cost out of that. But one of the significant things that I have seen is also in terms of the amount of data that you send over the wire. Which means, let's say if you have to load some data on your application, you would want some data from the backend obviously to be coming there. And then the data formats about how you send it out matters significantly. Someone could say that, for, let's say if a key is name and value is Kausal, someone would just say N and Kausal, right? Instead of that, someone could even say a big, name or first name or whatever, so kind of things, right? So one is the structure at which you send the data out, and also what kind of optimizations that you do. I mean, there are multiple levels of optimizations, compressions that you can do, right? Level 5, level 10, broadly compressions and everything else. So that also matters significantly. And also, I'm a big fan of not using JSONs and then use, some sort of a binary format, right? A protocol buffers. Once we started doing that, I'll tell you a real world example, right? We are in stocks, and then we have to power live ticks to all the users, which means that I don't have a control on the incoming data, because as much as the trades happen, so many ticks do come, and then I'll have to send all of that. The moment I start sending all of that, users' devices get choked like how. And then once we started changing that structure from JSON to a protobuf, it reduced the amount of data out significantly by about 60%, which just, and then that is just one of the examples, right? So there's a lot of optimizations that you can do on that. Adding to that, there is one more blind spot that is on S3. Yeah, because you keep storing all the documents. You keep storing the documents from the time eternity, and some of them most likely uncompressed because, and people use, your developers use a lot of it for testing and then putting some documents, and then of course for loading them again, lots of things, right? So you have lots of documents historically, and then you don't purge the documents, and you don't store them compressed. So by compressing, you will actually store significantly, and then you save the amount of space that you are using significantly. And one more interesting thing, there are how many operations, right? It also matters. How many operations are you doing there, right? Each operation is also a cost. Each operation on S3 is a cost, right? People just simply do a get, right? But it is a cost, right? How can you avoid some of the get, I think Siva was talking about, caching wherever you can. And also what we learned also is there is this, in AWS, you also can do what is called as a tiered storage classes. You can actually use that to significantly save a lot of cost on the storage. And this is also one more funny incident where we end up spending a lot more cost in an attempt to over provision the reserved instances, because people reserve instances, and then people reserve instances because in this world where things keep changing so dynamically, softwares keep evolving so faster, and if we don't evolve, we are gone, right? So software keep evolving so faster, and then people just reserve. I've seen many cases where people reserve databases and all Elasticsearch instances and all of that for 3 years. What if there is no use case? What if some regulation change happens and there is no use case for that, and or you might want to re-architect. So a lot of these kind of things, right? Instead of, let's say you would probably, and in fact in the case that I was talking about, we lost in an attempt to save $10,000. After I had to cancel the reservation, we had lost $13,000. Right? So all these do matter. These are blind spots, in my opinion.
Thank you, and that was really enriching, right? Especially reservations, it's very tough, right? Doing the right set of reservations. Over to you, Ranjitha.
Yeah, I'll slightly take it's a tangential thought, okay. To be very honest, I think today we have traceable tools, we have monitoring tools, we have tools to tell me that where my cost is going, right? It is at very granular level. The tangential thought is whenever a question is raised to an engineering team that this is your cost, the answer is this is needed, okay? The question of why do you need so much should start happening. That thought leadership should come in, is what I say. Like for example, if I say that I need to have a perf environment, yes, that is needed for my development life cycle. But do I need a perf environment for that team, or can it be shared? Because this is not something that is used by the team all the time. Okay? So this thought process is going to bring a lot of difference in the way we look at costs. Okay, that is one. Second, for example, in the greed of optimizing my applications for lower latency and higher throughput, many a times we are like everything should be a microservice, everything should be a nano service. Yes, it's beautiful on paper, the architects would love it, but is that the need for the business use case that you're actually working on, right? So that is the thought process that should bring in a lot of cost savings, because when you ask the same question to an architect, they will be like, yes, this is the need. This is a beautiful piece of code and beautiful piece of architecture. But you ask the CEO who is spending the money on that infrastructure, is like, why do you need 5 VMs, right? So there is a perspective change there, which means that thought leadership is going to bring in a lot of cost savings. This is where I'm losing on. It's there, okay? Everything can be shown. Like, yes, the network, you're going there, it can be cached. you have a lot of unused CPUs and all that stuff. But unless that is changed in the code that I deploy, nothing can happen. So I would really wanted to bring in a different perspective there. Yeah.
No, that's very interesting, right? Because I think it is us being very narrow-minded, think of like, oh, this service is painful, this particular thing in this particular cloud is painful, but also this whole understanding about how the cost should be accountable to the teams, I think that's even more important, right? And that brings me to a question to Vishal, right? Vishal, you run a large org, right? And what Ranjitha was saying earlier, right, bringing in accountability, right? So how do you balance this performance and cost efficiency without compromising scalability? Because if I tell an engineer, hey, reduce cost, he's like, hey, are you okay if my application goes down? And at that point, we all say no, right? So how do you balance performance and cost efficiency without compromising reliability?
Yeah, like we say in distributed systems that the CAP theorem, right, between consistency, availability, and partition tolerance, you can have achieved two. And third one you have to balance. Similarly, in the cost, it's a triangle between performance, reliability, and the cost. So typically, we'll see there are few models, like 3 models. If you want high availability, high reliability, and high performance, then there's a high cost to that. So we will have applications, we will have such services where we need to ensure that the latency is less than 10 milliseconds, and my downtime, I need 4 nines, 5 nines. There will be certain such use cases. For that, we are okay with high cost, but then most of the workloads, most of the services will fall under where we want to optimize for cost with the optimized reliability and optimized performance. So that's where we'll see the architecture. Mostly it is we have auto scaling, we have the right sizing of the infrastructure, and we also are very cognizant about whether we are targeting for 3 nines, 4 nines, or 5 nines. Right? We cannot just build everything for 5 nines because cost of that, not just the cost, but the operational cost of doing that is also very, very high. Then the third aspect will be where you have low reliability and low performance, and the cost is also low. Typically, your dev environments, lower environments, you are okay with that. UAT environment, once in a while, you are running on a single pod. You don't want to run on 5 pods minimum, the way you run on production. So these are few mental models where we say, okay, some workloads will require high availability, reliability, and performance. For that, we are okay to spend 3x, 4x. But then mostly 95%, I would say, falls under optimized for your performance, reliability, and cost. And then there will be a lot of use cases where we can live with low performance and low reliability. Other aspect is, we also need to be very clear about unit economics about our services. That what is the unit cost of this service if it is running at 200 RPS? How many CPU cores I need? How much IO I need to provision? Then I know in the capacity planning that, okay, if my service goes from 5x to 100x as my product scales, then this is the cost it's going to be. That also reflects the design choices I am making today and how it will reflect in 2-3 years when the product scales. So that unit economics of my service, my application has to be very clear. Second aspect is the cost of doing business. Like what is cost per transaction? What is cost per onboarding a user? So from infra perspective, there are a lot of things, like a lot of networking, storage, your IO and your instances, services, a lot of things are coming together. But end of the day, it rolls up to cost of doing business. So it is very critical to track these metrics, which is cost per onboarding user, cost per transaction, cost per payment, so that we know that what is the ROI we are getting by provisioning this much of infrastructure. And and I think SLOs are very, very critical. Without SLOs, we will end up over-provisioning. We don't even know that why we are making certain choices in terms of which type of instance I need, C class, M class, R class, whether I need Graviton versus Intel, right? There are n number of choices we need to make. It has to translate, it has to come backwards from my SLOs. I think these are the few things which we need to consider before we are, when we are deciding a right balance between reliability, performance, and the cost.
Just want to add on here to whatever he said. That was a very beautiful thought of like today we have dashboards for my throughput requests per second and stuff, the cost per transaction should be one of my dashboards. Like just yesterday, there was a paper released by Gemini. The cost of one read conversation that happens with Gemini is around 0.25 watts of electricity, which is about 9 seconds of me watching TV. Okay, and then it's about some 9 drops of water consumption. That is the carbon footprint of it. I think that is where we should go towards. That is the North Star. I think if each of our apps and engineering can come up with that metrics of ours, then I think we are there. We become accountable.
No, that makes a lot of sense, especially on that front. What's your take on this one, Manoj, right? Like, you have got a very similar problem, right? Your customers are of that size, scale, and it moves very fast. So how do you manage this internally?
See, it's funny, my team is responsible for both cost as well as reliability, right? Sometimes reliability is with a different team, and cloud cost and cloud provisioning is with a different team. But in our organization, both is taken care by the same team. So I just wanted to share, I think Vishal covered pretty much everything, but I would like to call out few important things where you can leverage a lot of cost saving. One is have the differentiation, right? I mean, we call it as the criticality of the application. Clearly call out or classify your application as critical, high critical, low critical, and other things, and have different SLAs and different throughput requirement for them, because based on that, you can play a lot with the provisioning as well as, having a different set of complete setup which can keep your cost down. One thing I wanted to call out is the architecture, ARM versus Intel and AMD kind of a thing. If you guys are not explored ARM, I mean, you should definitely explore ARM. Worst case, try to run your workload in AMDs. Again, there is no one fit answer, right? But try out those things for the lower critical applications, right?
What I'm hearing from all of you is production is important. Spend extra money, it's all right. But the lower environments can be experimented faster.
No, production versus non-production, right? Non-production run in SSDs, HDDs and spot nodes also. I think not many of them talked about spot nodes. Spot node is something you guys have to explore. I was talking about even in the production workload, you should have the classification. There are certain workloads, the SLAs no need to be so high. So it's very important for you to understand with the business owners and classify them and run your workload according to the SLAs defined. And you don't need to even have high availability for certain applications. I think many of you guys may be able to relate it. Not all the application needs to be highly available, but most of the cloud providers, they push high availability configuration by default. You being the owner of deploying this application in production, having this visibility of whether this application is super critical, like as Vishal mentioned, right? Do you want to do 9.9999, or is it okay to have some downtimes? Based on that, you can tweak your availability configurations and also the performance tier of the resources it is using. I think.
Yeah, that's really great, because I think this is a very big oversight. We do not classify things. Correct. And it's difficult, right? So we should solve it. And that takes me to a question, Swadhin, for you, right? You have done this in past, right? So what are the biggest mistakes, and you admitted that you made one, right? What are the biggest mistakes company make with auto scaling and right sizing, right? We have been all talking about, hey, let's put things on auto scaling, right sizing and everything. But what are the biggest mistakes that companies make? Yeah.
Sure. Since you are talking about the money we are bleeding in cloud, I'll take that perspective and answer this question. I was working with a edtech company. In edtech, the traffic is quite spiked, right? You know that your class is going to start, let's say, at 4 o'clock. All the students were going to join at 4 o'clock, right? So initially, when we did not have auto scaling, we used to spend a lot of money in cloud, and we started auto scaling, which reduced the cost, reduced the instance sizes, when the class is not happening. But we had a auto scale without any check at 4 o'clock or whenever the classes were happening. And that was the biggest mistake. Because it can auto scale infinitely, right? If you don't have trail guards there, it can scale, and that's what we have seen multiple times, that it is scaling further, and it's not downscaling after that. So regular checks are very important. The auto scaling configurations are very important. I think we learned lesson hard way, and it was long back. And then same with the right sizing as well, right? When you think that, hey, we have right sized and we think that this is the maximum traffic we can get, we won't have downtime in production, what you end up doing is, most of the time, you are underutilizing your resources, right? You are wasting 30–40%, and that's where you start thinking that we will reduce and we'll put auto scaling. So I think that right check is very important. Keeping regular check weekly, or how big is the company, depending on that, you should have regular check and figure out what is the trend which is going on. AI can also help you there, figure out what should be the configuration for your auto scaling and what should be the right sizing. So yeah, I think we used to do a lot of mistakes. Now there are a lot of companies which are helping you, and the AI, of course, I mentioned. So yeah.
No, that's a very interesting perspective, right? What's your perspective on this, Kausal? Yeah.
I just was hearing what he was saying, right? So one thing to add upon was, whenever there are any applications which are memory intensive, people end up doing an auto scaling on memory. So that's a very some habit that I've predominantly seen. People just do it because providers are giving you auto scaling based on CPU and memory, and then just because they're giving me, I'll just put it, right? And then what happens with that is, if there is a memory intensive application, even if you auto scale, let's say there is some in-memory cache or anything, even if you auto scale, it keeps on obviously accumulating memory, and then again keeps auto scaling again infinitely, like he was telling, right? So to understand what kind of auto scaling is required in the context of things, and also while right sizing, right? I've seen people make these kind of small mistakes on a very mission critical applications which are running on, let's say, 500 megabytes memory, right? Where, let's say, your utilization is about 40%, let's say about 220 megabytes, right? And then people started optimizing on that, saying, okay, let me put it at 300, right? So one small memory leak and you're done, right? It's such a, I mean, you can't be penny wise, pound foolish, right? So you don't want to be, saving where you can't really save a lot. What you need to think of is some sort of a use cases where you want to see, does it fit my application? Is it something that my application merits? And then only just do it, right? So, and one more thing that I've also seen, and which happened with a couple of our competitors as well in the space that we are operating, is whenever there was a huge spike in the market, right? Let's say a budget day or an election results day and everything else, right? So people just blindly add number of servers, the number of pods as we call it, right? In today's world, pods or number of containers, right? So people just don't look at the number of database connections that are emerging out of any container. Obviously, these days we have the max, and then the max number of idle connections and everything else. So if you don't look at that and then just blindly scale the number of containers, your database just gets killed. Your database gets killed, and then that happened with a few of the competitors as well, right? So it can happen. It does happen, and that's exactly why we need to know, while I'm actually scaling up, I need to be mindful about not just the current system that is in the discussion, but also the underlying systems that it actually calls, whether it is some databases or whether it is underlying microservices. So we need to be mindful about all of that.
So what I'm hearing from you, Kausal and Swadhin, is, hey, yes, auto scaling is great, but at the same time, you should have better architecture. if you don't have a better architecture, it's not going to solve your problem, right? So doing that better architecture along with this auto scaling and everything works.
Yeah,
much better.
architecture is one part of it. Then the other part of it is that looking at multiple dimensions of that, how many network calls are you making out, right? Let's say even if I'm using a very highly performance, cache like Redis, right? The moment I start doing more number of network calls, you need to also see what happens to that. Because it's also like some of them are single threaded, and also every database has its own merits and demerits, right? So you don't know when you go down for what reasons, right? So not just looking at a single system, but also looking at the systems that are downstream.
No, definitely that makes a lot of sense. And that brings me to another perspective that I've been thinking about, right? And this question starts with you, Sri, this time, right? You run a large complex org, distributed location, distributed time zone and everything. How can we enforce cost accountability across engineering, finance, DevOps, procurement? In fact, I was recording a podcast yesterday and somebody told, hey, I make everyone role play each other. I was like, yeah, that sounds good when you are in a training room, but in real world it doesn't happen. So what are your tips and tricks to enforce cost accountability? Yeah.
Yeah. So before I answer this question, since we went very deep into transactional and double clicking, most of the leaders did that. So I'll probably spend a couple minutes giving some strategy. How many of you in this room are accountable for cost optimization in your company? Fantastic. So we are talking to the right audience then. So I'll give you a 3-year strategy that worked for Freshworks. So with today, basically I completed 3 years at Freshworks, by the way, August 22nd. And when I joined first, obviously there's a cloud engineering, there's AI, and there are a lot of other responsibilities. But one of the things that I felt was, I think looking at the cloud spend, I think we need to have a strategy. And the strategy had 2 parts to it. One is outcome. Second thing is the approach. Outcome is all about what is that you want to achieve at the end of it, and you need to have a dollar value associated with it. And without having no knowledge about the infrastructure, the maturity of the tech stack and everything, but we went ahead and said, hey, year 1 we are talking about, let's put a goal of about 10% reduction. And this one is roughly about $4 million, for the whole year. And then people started actually working towards it. And then year 2 will be based on what is, how you achieved in year 1. And depending upon, are you scratching the bottom of the barrel, or like you actually find more. So you can either increase or reduce it, right? And then year 3, you'll actually follow based on that. So that is the outcome part of it. So how many of you played Secret Santa game, in any part of your life, right? You have done it. So you're so excited because you know something is hidden somewhere, and you will find it for sure at the end of it, right? So it is always safe to assume there is money left on the table, and that's how hyperscalers are like $4 trillion companies today. Talk about Microsoft, Amazon, Google, $3 to $4 million this thing. There is close to 80% margins there. So it is safe to assume the money is left on the table, but then you actually start with the goal. The second part is the approach part. So approach, there are 2 aspects to it. One is the cost ops, and second is the cost engineering. Cost ops is all about having reservations and RIs, going from Intel to Graviton or Intel to Spot instances. All this we could do even without touching your engineering teams. We could do it, right? This is a cost operations. But cost operations has a lot of limitations in terms of what you can do in terms. And we always hit the brick wall saying that, oh, you know what, if you do any more savings, you'll end up bringing it on the application. Then basically I started introducing the engineers. Engineers will actually look at the architecture. So one good example I can give you. So we are one of the largest ticketing customer support companies, software companies in the world. And we have millions and millions of tickets in the system. When we looked at it, each ticket, its body, its attachments, everything is in RDBMS. That's how it was architected, and then cost went up. So fundamental architecture was changed to move all the attachments to a blob storage, gave straight away 1 million per year savings for us. But nobody actually thought about it. It's been like that for 15 years, and then we kept scaling that way. So that is one example. Like that, we came up with 27 action items from the engineering perspective, and we kept going after each one. So this first year, we achieved 5 million. Second year, we went to 4. In 2025, we are on track to actually get about 3.5 million. But the learning was there is always money to be made. And 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 you won't imagine, our company's revenues went from $450 million to $900 million in last 3 years, but we stayed flat at the cloud cost, right? So which means there is a lot more to be done. And now I'll get to the actual answer. So accountability, I think, was the fundamental way how we achieved. So we have 5 different business units, close to 120 AWS accounts. And then you know how the spend goes, like uncontrollable everywhere. So I think the number one thing that we did was get the cost attribution, where you could actually exactly see each BU, each product, and each service under the product is what is the resources used and what is the the cost that is happening, and then you basically automate all those alerts. And towards the end of this talk, we also have another topic to talk about AI. I'm going to talk about how we are using agentic AI to trigger some of these learnings to, and bring the accountability into the system. But I think that helped us a lot. And one of the reasons why now the team's coming back to us saying that it became a big deal, actually. So we started rewarding the behavior of cost optimization and saving. So people started actually coming back and saying, hey, you know what? This quarter, we ended up saving like 200K. And then we basically went and rewarded them. So it became a mindset, it became a culture, then it became a function where, hey, whenever somebody sees Sri, okay, he's going to talk about saving some cost.
That's a great, first of all, congratulations on 3-year mark with Freshworks.
Thank you.
Yeah, that's great. And great examples of how you have done it and what is the right way of doing it. And this also brings me to Ranjitha. Ranjitha, you have talked about culture before, right? Like the carbon footprint and other things. So how do you enforce this accountability at Phonepe? Like, again, the same thing. Your transaction volumes are high. It's very easy to make a small mistakes, right? Like what she was saying, putting this files into an RDBMS, right? So how do you enforce accountability across all these teams?
I think accountability, the word comes in when somebody who decides is different and somebody who does is different. When the doers are different, when the one who bears that brunt is different, the accountability comes into picture, okay? So in the way we structure our orgs, this is always like that, somebody decides on the money, there is finance team, then there is an SRE team, DevOps team. Papa, what can they do? It is like, they come and say that yours is unused and the developers would say, I need it. That is where the accountability comes in, right? So 2 things, when we have disoriented org structure, we get into these issues of who is accountable and who is not. So the org structure, when you create org structure, create such that the one who does also pays for it. That makes them accountable, which means that first enable them by providing the right tools where they can actually see how they are performing, which is the first one, right? Which is about bringing in the visibility of how your infrastructure for you is playing around. That is, which is what I say is enable, then make them accountable, right? Enable them. Second step would be making them accountable that this is your cost, this is what I would give you because this is the revenue that I get from you. Okay. And the third one would be that trackable. Right? While I do that, I should also track it and follow through to ensure that that is within the guardrails. Just 3 it is. Enable, make them accountable, and then make it trackable. Okay? This is one. And the second thing, I think when we were in Myntra, like he said, there is always some money on the table. We brought up something called as Cloud Champions, which is about who can actually try to reduce cost for me. We had these pilot teams who would really look at where are my costs which is leaking and then use those checklists and templates across the teams. Rather than every team doing it, there will be always something common that can be used across. So we came up with this concept and that drastically reduced because there were a lot of things which are common in the way I use my database, in the way I use my connectivity, right? And then in the way I use my developer servers or performance environments. So this was one of the steps that we used at Myntra, which actually reduced a lot of our costs, and we reduced it drastically. Second, one thing that I also wanted to tell is taking 2 steps back, right? It is always, we always decide that yes, we'll go to cloud, but there is many a times, most of us overestimate ourselves thinking that, okay, I know what is that is needed to move to cloud. And we always do something like whatever is there in here, I will just replicate it as is there. And that is never cost efficient because we are just moving from one place to another place That's it. So thinking of cloud first architectures or trying to use who are actually good at it actually helps it to ensure that when I'm migrating, when I'm transitioning, look at what are those which we should be doing than just replicating as is. I think these 3 steps is what I think makes it.
That's a great way of looking at it, like when you have somebody who's spending but the other person actually checking it. It's a good check and balance, right, that gets into place. Great. I think we have talked a lot about problems, a lot about doing the best practices or culture setup and everything. Let's jump a little bit deeper, right? And this is my question to you, Mohan. How do you optimize storage, networking, or data transfer costs, right? What has been your harpoon or the magic tool or the magic wand? How do you do that? Optimizing storage, networking, and data transfer costs.
So PayU as a payments company, right? So during COVID as well as post-pandemic and all, our volumes have skyrocketed, right? Even now also we grow more or less almost at 20 to 30% every year in terms of our volumes, right? So when we are skyrocketing, ensuring that our business works and new features were like launched faster becomes absolutely important, and teams have autonomy to build and they moved faster, and a lot of features were built. We have improved observability, ensured that the performance were like maintained, and at the same time our costs also have skyrocketed, right? So we started having a lot of tough conversations with the finance teams, right? So eventually what we have started is we have created an entire cloud optimization task force in our organization, which has the list of architects, a lot of architects, then SREs, and we also have collaborated closely along with the AWS team also, right? I'm just telling about that experience of the transformation that we have done, which enabled us to reduce the costs, not just application level, but also at infra, then also at the storage costs and all, okay? So for what we have done is, we started at the audit of how is our infra, how is it being used and all. Few things which we have observed is, when we take about our server infrastructure servers, we are heavily into AWS, okay? So the kind of instances that we are using is absolutely important, like let's say whether it is compute optimized or it is memory optimized, right? So these things are absolutely important. Taking a view of what is our service and what is our instance type that we have is very important. We are also heavily onto Intel processors, so it was like legacy in AWS, we were using them, and that is how it was, right? When it comes to storage also, right? So when we look into storage, we have huge amount of data that is coming in and it was not getting properly archived. So the data starts getting piled up inside our systems. Logs and all, because of not having efficient policies, again, there was huge TBs of logs which were there inside the system, right? Then again, networking, huge amount of data, like so much of chatting which is happening along with our microservices, and also we observed so many action items when we have gone through it, right? Subsequently, we started our optimization work. For example, when I talk about instances itself, for example, we have moved to Graviton as such, right? Graviton is very cost efficient, especially with respect to the performance that we are getting and the cost we have. It is almost like 30 to 40% better compared to Intel-based whatever we have, right? So we have done benchmarking, and then we have moved almost like 70% of our workload to Graviton at this point of time, right? Second thing which happens with servers is you will see a lot of servers, some of them were like critical, you have huge volumes of traffic which is coming, but some of them were like in nascent, you have innovation, you have built something, right? The traffic will not be less. But the moment you are in EC2 instances, you are like stuck, you have to ensure that auto scaling, everything is done, right? With instances being there. So we have looked into it, we identified optimization areas like moving to EKS is another big initiative which we have taken, which enabled us to move to EKS, like almost 50 to 60% of all our servers have moved to EKS, right? So these are all from server's point of view, but when it comes to database, right? So one thing is many times when we are scaling, right, we understand the importance of moving to for example, analytics and all, we move to Redshift, a lot of reports move there. But what happens is before Redshift, we also have some traditional systems like MySQL. We have something like a database Maria database which we are using, and that is being used for analytics workload, and that is a self-hosted database which was running in our production for some of these requirements, right? A lot of legacy reports running. Again, that is a huge effort which teams have to take. But the thing is, the decision of taking it moving faster is absolutely important to reduce our cloud costs. So there are huge number of teams which have come together to actually shut down this entire MariaDB infrastructure, and then we have moved all our reports to the Redshift, right? So this is all from the storage point of view. There are a lot of replicas that gets created inside the databases also, right? So we need to be careful about how is the data flowing, whether we are creating redundancies, whether we can actually take the data from other services. All that becomes absolutely important. I mean, having that view of architecture and ensure that we take care of them will have a huge impact in terms of our cost savings. Again, for logs also, right? We have to have tiering in terms of S3 storage. For hot data, AWS provides all those policies, right? For hot data, warm data, as well as for cold data, we should ensure that our data gets stored with the right policies being set up. Taking that holistic view and setting it up also will again give huge amount of savings in terms of storage as well. When it comes to networking, again, what happens is there is so much of data that we actually transfer in between microservices. There is caching that we do, so much of data that we pull, right? So having compression is going to really make huge difference. We don't realize it only when we make it mandatory, create a checklist, ensure that all the teams follow those practices. It will have a huge impact in terms of how much is the network traffic load that we will reduce. Similarly, transitioning from NAT to VPC and all, that is one thing which we should carefully look into it and do those changes. That also something which gave us huge benefits as such, right? Few more things probably. There are huge number of optimizations which were done, which has significantly helped us reduce our costs, like almost like we have taken that target within 1 year itself. We were able to achieve almost like 30% cost reduction in whatever we have done, right? This is across everything, entire infrastructure cost, where we were able to accomplish that. From team's culture point of view also, teams have still the autonomy, but the thing is every team now looks into cost, right? Especially looking into the cost in a way like they have their objectives, and they also, along with their business objectives, they will have cost also as an objective where they will find opportunities to actually reduce, right? Now, we have a transformed culture in our organization where teams come back proactively stating that these are the things that we can do, this is what we will take up, and this is what we will change. That's a drastic phenomenal shift we had in our organization. Yeah. So overall, what I want to say is, for us to be, it's not only about moving fast, it is also about moving smart in terms of our costs is very important for our success. Like at least in payment aggregators, the cost per transaction, like having that extensive dashboards is important, and we have provided visibility to the teams also, such that each one of the services, we exactly look into cost per the transaction at a service area level. In that way, teams are more accountable and see that they will be able to manage their costs well, right? For our winning, we strongly believe that it is absolutely important, and we should consider cost as the first citizen. That's what, yeah, thanks.
That's great answer, Mohan. Probably you can write an encyclopedia page on it. Like, there's so many guides. Like, I could literally, I wish I had my laptop. I would have literally typed all of them in, right? That becomes a very handy guide on how you can actually move and save so much of cost. And that brings me to another question to you, Swadhin, right? We all buy RIs and SP. Kausal was just talking about buying 3 years RIs and everything, right? At what point, how I can do balance on it? Right? It's very easy to buy, right? On a single button click, I can go buy RIs. I can keep on changing my savings plan dollar, right? But how do we manage the savings with flexibility? How do you do that?
Sure, I'll take another example. I worked for largest e-commerce, Flipkart, I mean, like 6-7 years back. So there we learned that there are some traffic which is steady in nature. You know that this traffic is constant and it will be across the year. Something like warehouse traffic or pin code services, which will be constantly hit by your customers. So those we can put in RIs. RIs are something like, let's say you are staying in a rented house for 3 years in the same house. And saving plan is like you have fixed budget, which you can, get into different hotels, right? So, so we utilize 30–40% of our traffic in RIs, where we know that the traffic is steady. And then that's how we balance with the saving plan as well. We had some dedicated plan which was initially was with AWS, and we later migrated to on-prem. But when we were in AWS, we had fixed budget for saving plan, and we were committed with AWS, which we're utilizing. So I'll say that balance between RIs where we have dedicated and steady traffic, which which is going across the year, and somewhere where the sale is going to start, and there will need a lot of spot instances, and you need a lot of auto scaling, and you need to spend the committed amount. There we can use the saving plan. So balancing between both is important depending on how your business runs.
That's great. And that also brings me towards the last question for our panel, right? And I think this is for you, Sri, right? How can AI move FinOps from reactive cost, right, to being a proactive optimization, right? I've heard a lot about it, right? Because I do cloud economics. A lot of people tell me AI for FinOps, FinOps for AI, and it's full of buzzword. And you told that you have done some agentic automation. I think everyone is interested to understand.
So the host is stood up here, and then we are almost at time, but any tech session is incomplete without speaking about AI. So, so in Freshworks, we built an agentic solution, which is built on top of LLMs, where, so we are a multi-cloud company. We are on AWS. All of the cloud is on AWS, and all of the AI traffic goes to Azure, and then some of the analytics traffic goes to GCP, and then we have Snowflake, Databricks, and there are 100 other integrations. All of the cost goes into one single cost database, and it is actually goes into the vector database of the AI, and it is integrated with the Slack. If you have teams, it integrates the teams as well. So, and it has a different personas. Everybody who spends, who saves, who budgets, gets access. So say who spends, like all your developers and everybody who provisions hardware, go to Slack and then say, hey, how is list of stuff that I'm using today, what is the potential of saving, what can I do to do better, everything is available in Slack. And then finance has finance persona, and the cost team has their own persona where they have a super user access. CFO has a gross margin level kind of insights that you can actually get. All this is actually baked into that, and we actually are partnered with the team, companies like, we have Amnic here, and then we actually built it. It took us about 3 months or something like that. Now, it's called capacity democratization, which means, imagine, when you know that something is shortage, you hoard it. Especially during the COVID time, we all went and bought so much stuff that we don't need, right? Thinking that things will actually get closed out. So, but when people know that there is abundance, they actually tend to use when they need. So the democratization really helped us. And hit me up on LinkedIn. Happy to share some of those information. But I think it's time to take the game to one level extra. And AI does all the work for you. It does analysis. It does information pulling from all these different clouds and tells you what exactly needs to be done. But more importantly, it is that on your phone, basically whatever question you ask, basically you get from the cost perspective.
That's great, and I think that brings us to the close of this panel. First of all, a big thank you to all of you, right? I think this couldn't have been more engaging and more productive, and trust me when I'm telling, right, I record podcasts, I keep on talking to a lot of people, you guys were very informative. I think I had a lot of spot-on answers, and I think if I have to really summarize, education, accountability is definitely something that we all try to drive in the teams. Then finding inefficiencies, I think it's not one team's job, it's everyone's job, right? That's what I'm hearing. And obviously AI, right? As she just said, right, no meeting can finish without an AI chat. Yes, you have to get onto agentic bandwagon as well. Thank you, everyone. It was great having you all here, and that was my time.